The empirical formula of a molecule is the lowest whole number ratio of atoms of elements in a molecule. In year 11 and 12 chemistry, you'll have questions where you need to find the empirical formula of a molecule. So that means you'll need to find the ratio of atoms within a molecule, and that's going to be done through mole. The way we teach this is through a 4-step process, and it's written just above here. Find the mass of each element and convert that into mole. Once you've got the moles, find the basic ratio of the atoms to 1, and then you can find that number in a whole number. I didn't explain that very well, but the best way of doing this is through an example. So let's have a look at an example. Some examples above here. Find the empirical formula of a substance that contains 68.4% chromium and 31.6% oxygen. We're going to go through these steps. So first of all, I'm going to set it out and say I've got two different atoms. I've got chromium and oxygen, so I'm going to put them in two columns. And then I need to find the mass of each of these elements. Now, I'm not given mass in this question, but let's pretend I've got 100 grams of this compound. That means 68.4% is chromium, which 64.8% of 100 is 68.4 grams. And that means my oxygen is 31.6 grams. So in effect, my percentages are my mass. Now I've got my mass of my elements, I then need to work out how many atoms there are. So therefore, what I'm going to do is I'm going to convert that mass into mole. So I'm going to take my mass of my substance divided by the molar mass of my elements. That means I've got 1.3 mole of chromium and 1.98 mole of oxygen. So my ratio here is 1.32 to 1.98. They're not whole numbers, so I need to get it to something that is a bit easier to work with. So what I'm going to do is I'm going to ratio the chromium down to being 1 by dividing it by itself. To get the oxygen in the same ratio, I need to divide that by that number as well. So what we're doing is we're dividing our number of moles by the lowest number of moles. So both of them are divided by 1.32. Dividing it by the same number means they're in the same ratio as they were before. It's just an easier thing to work with. So here you can see we end up with 1 chromium for every 1.5 oxygens. Still not a whole number, but let's just scale it up until we get whole numbers. And if we times the whole thing by 2, you can see our ratio is 2 to 3. That gives our empirical formula of Cr2O3.